Okay, so now we're going to be moving towards the next part of our system software chapter. And basically, we're trying to understand the representation of the working of your translation software, which is also another type of system software. Now, this topic relates to BNF. Now, BNF means Backus norm. In simple terms, Backus norm is a language that is used to define languages. So as far as syntax, if you remember what syntax means the rules that are used to write a particular language. So if, for example, C++ requires a semicolon at the end of any statement, that is part of its syntax. Now, why is my, if I don't add a semicolon at the end of my C++ instruction, why does my C++ compiler highlight that as a syntax error? Because these were the rules that were defined at the time of C++ creation. Now, this essentially Backus norm is a language, it's in itself a language that is used to define a syntax of a language. So for example, if you can see here that what is an identifier? Identifier, or in fact, we can say that what is a digit? According to my language, this hypothetical language that we're talking about right now, a digit can be anything from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what do these individual symbols mean? What does this symbol representation mean? We'll be looking into that in a bit detail, but simply, as you can see here, I have specified each and everything, and there are more details that are not mentioned here, but as I'm trying, but the attempt here is to specify each and every aspect of this language so that my language translator is clear for what is considered a valid syntax and what isn't a valid syntax. Now, representing the language syntax can be done in two ways. One is known as the BNF, which is this representation over here, and the other is known as a syntax diagram, which is this over here. Now, a syntax diagram, consider the syntax diagram, which is this one right here, that specifies the rules for defining an identifier. So let's study this, for example. Now, for something to be an identifier according to this language, how do we know that this is specified? This is a rule for identifier only. Well, first of all, it has written here that this is the rule for an identifier. Okay. Now, to understand this, you notice that there is a direction, there's an arrow. So it sort of gives you an idea of the flow. So if I start here, I have to take this path, and I have to, this is where I end, this is where I start. And in this path, I have to access this thing for sure. This thing I have to have for sure. This comes for sure. However, if I come over here, there's this aspect of looping here. And in that loop, I can take either this loop or I can take this loop. So now what does this diagram represent, first of all? First of all, you have to understand two things. These arrows represent your flow of, representing a particular rule. So if I start this, I have, and I go till here, I have to satisfy all of these things mentioned here to be able to satisfy this rule for identifier completely. Secondly, there is this box here, this rectangular symbol over here. This rectangular symbol represents what is known as a non-terminal. So this is known as a non-terminal. Now, by definition, what a non-terminal is, that it's an aspect of a syntax that requires further definition. So what this means is that, okay, it's a letter, but what is a letter? That definition is yet to come. We don't know what a letter is yet. So as far as this definition goes, as far as this letter goes, that identifier, this rule goes, that this identifier require the first thing to be a letter at all costs. Now, what is a letter? That's a separate definition. That's a separate issue right now. But we just know it's a letter. And since it's a non-terminal, that means my language, my BNF or my syntax diagram should represent what a letter actually is. We'll look into that detail as well. Okay, now after I have used a letter, whatever a letter is, after I've used a letter, I can either just end it there, because I can go from here to straight all the way here, and that's it. So that means that for an identifier, it's possible for me to have a single letter only. After reading a single letter, I will exit this rule from here. I can do that. On the other hand, I also have options of allowing multiple letters in this identifier as well. So for example, if you have an identifier says SUM, sum, that's a perfectly valid identifier, considering that S, U, and M are valid letters, which from the looks of it, they look like a valid letters. So let's just say that sum is a letter. Oh, sorry, sum is an identifier. So for example, if I have sum over here, sum is a perfectly valid identifier. Now what that means is that, let's see if this, according to this rule, is a valid identifier. So let's start from here. Is this first letter a sum? Sorry, is this first letter a letter? Yes, it is. So that rule is okay. After that, if I have multiple letters, what rule am I using? What part of this rule I'm using? I'm actually coming back to this as a loop. So I've got one letter here, and that's U, then another letter here, and that's M. So that basically, according to this syntax diagram, sum checks out. Sum is a valid identifier based on this rule. Okay, we can also see another aspect of this rule is that, for example, if I have sum and I have say 14 here. Now, is this a valid identifier? Does this look like a valid identifier to us? Yes, actually it does look like a valid identifier. How? Well, the rule states that you can have one letter followed by any number of letters. So I've got S, then U, then M. And then it also specified that I can also have a combination of digits as well. So that means that 1 and 4 are also part of this. And after using that last 4, I can exit this syntax diagram. So that means sum 14 is also a valid identifier. Now, this also means that I can have any length of letters and digits. But the thing that it is making sure that I cannot deviate from is that I have to start with a letter. I have to. There is no option here. There's no way of skipping this rule. So if I had something, for example, like this, I can have something like this, for example. Then that means that I can start with either a letter, or I can start directly go from nothing to directly a digit. But what I did here was that I specified that it has to start with a letter. And from the looks of it, this is how we actually see identifiers. All identifier, all variable names, class names, object names, record names, subroutine names, whatever they have to start with a letter. Now it's not specifying are they capital or small, whatever it is, it's not specifying that, but it is specifying that it has to be a letter, okay? Now, this is how we're gonna interpret your syntax diagram, an average syntax diagram. Now, there's no example of what for example, non-terminal will look like, but this is a non-terminal. What a terminal will look like, we'll look into that in a bit, but this is what a non-terminal looks like. What this means is that there is going to be a further definition of what a letter is. There has to be more details of what a letter is. Now, let's look at the exact same thing here with respect to a Backus norm. Now, this rule only represents this first part of my BNF statement, only the first part. Now, if you can see here, it says that identifier is defined by letter followed by any combination of letters or digits, any combination, right? Now, if you look at this first line over here, we can see that it's the word identify is written here, just like it was written over here. But I also see that it has this symbol over here, these sort of, greater than, less than symbols over here. Now this symbol, this combination of symbol in Backus form means that this identifier is a non-terminal. Wherever you see non-terminals in Backus form, the difference between Backus form and your syntax diagram is that Backus form uses this symbol to specify non-terminals, whereas your syntax diagram represents non-terminals using this rectangular shape. Now, as you can see here, this rule specifies that I can have one letter and I can call it an identifier. That's it, finished. And that's fine. So according to this, if you look at this, identify is a non-terminal, agreed, because we're defining it right now. And this symbol right here, it is to be read as defined as. See, defined as. So what this means is that identifier is defined as. So defined as what? Identifier can be defined as either a letter, or it could be identified followed by letters, or identified followed by digits. Okay. Now let's pay attention to this bar over here. This bar is read as OR. So basically what this means is that for this rule to be satisfied, I have to choose between this, this, or this. I have to select for a valid identifier. I have to select for either one of these rules to be considered as a valid identifier. So this symbol is read as OR. So letter, it could be either a letter, or it could be an identifier followed by a letter, or it could be an identifier followed by a digit. So this is how simply we're going to read it. But what does this mean? Why identifier letter? We'll be looking into that later. But right now, just try to understand the basic terminologies. So this is a non-terminal. This means defined by. This means or. And why do we mention or? Because if we're giving options for a particular rule, like we did over here, we said that it could be only a single letter. It could be a single letter followed by digits or letters, whatever it is. If you're allowing for options, this is where that or symbol comes in. Okay. Now let's look at what this symbol, this rule says over here. Now again, digit. See, digit is a non-terminal, as we can see here from the rectangular shape. Now, as I mentioned before, this is a non-terminal, and digit is defined by 0, either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. Now you notice that we have the same thing. We have OR symbols over here. We have OR symbols over here as well. But the major difference is that in this definition, I do not see any of these symbols, the non-terminal symbols over here. I don't see those. Why? Because these are terminals. And if they were terminals, the Backus-Naur form, the syntax diagram would look something like this. So if I have, say, for example, a non-terminal, it will be represented like this. This is in a circular shape. So like this. So this would be A, this would be B. Let's just say we're considering that A is defined, a letter is defined by either A or B or C. And we have the arrows like always, like this. And this is assumed for a particular language. My language specified that a letter, it can be either A, B, or C. So as you can see here, this terminal is represented by a circle. So if I'm using syntax diagram, wherever I'm defining a terminal, it would look like this. In fact, I have an example here as well. Look, so a digit is defined by either a 0 or a 1 or a 2 or a 3. Sorry, either a 1 or a 2 or a 3 or a 4 or 5, 6, 7, 8, 9, or a 0. So that is the rule specified for digits. And this is what terminals look like. They're not using the rectangular shape. And what terminals mean is that there is no further definition. There's no further options of what a 1 can mean. 1 is a 1, 2 is a 2, 0 is a 0. There is no further variation of this character over here. It will be represented as it is. But if you're calling something as a letter, then you have options. We can call something as a letter. It could be either uppercase or lowercase. Okay, what is an uppercase letter? Uppercase letter can be any one of these things. A lowercase letter can be any one of these things. So whenever we're mentioning non-terminals, we represent it with this symbol, and it means there is a further definition required. And whenever we're looking at a terminal, it means that there is no further definition required. As you can see, there's no further definition of what a 0 is. 0 is a 0. No further definition required. In fact, there's no variety of what 0 will look like. It has to be 0 like this. 1 has to be like this. There's no other definition whatsoever. Whereas wherever you have definitions, that means, or wherever it is a non-terminal, that means It's represented in this way in Backus-Naur form, and it's represented in a rectangular shape in your syntax diagram. Same thing goes with your terminals. They are represented in circular shape whenever we're talking about a terminal. So this is the basic terminologies of your Backus-Naur form. And in the next lecture, we'll be looking at how they are used. And we'll look at an example from one of your past papers and try to implement that in both your syntax diagram as well as your what you call it, Backus-Naur form.